So just a reminder then, without going through the whys and wherefores, which is what we did um, on Friday, the formula for a sum to infinity of a geometric sequence is given by u1, the first term, divided by 1 minus r. In this case, we would not use r minus 1. We definitely have to use 1 minus r. And a reminder also that we can only talk about a sum to infinity equaling a specific value if the common ratio r is a fraction. So that absolute value of r less than 1 makes it a fraction. Could be negative 0.8 or positive 0.8 or whatever, but it needs to be a fraction. So that's the formula that was given to you on Friday, and the y was also given to you on Friday. Okay, so example 10 there is just one example of a sequence that you could be given, and then a matter of just using that formula. So we can identify U1 pretty straightforward. U1 is 0.9. How do we work out the common ratio? You don't have to work out what it is, but how do we work out that common ratio, Iris? Preceding it. Before, yeah. Good. So one term divided by the term before it. So 0.09 divided by 0.9, which you could use your calculator for if you like. Or we could move the decimal point twice to get 9 over 90, and 9/90 is 1/10, and so we get a common ratio of 0.1. Now, I wasn't told, well, the example doesn't say that this is a geometric sequence, so you could repeat the action with the next two as well, so 0.009 over 0.09 to confirm. If you did that, you would see that it's also 0.1, so that's fine. So we're definitely seeing a geometric sequence here. We definitely have a common ratio that seems to be true for all terms on our limited knowledge. So that's fine. We've got those two things. Therefore, the sum to infinity is equal to u sub 1, so 0.9 all over 1 minus 0.1, which is the common ratio. So that's equal to, I don't think we need a calculator for this, 0.9 over 0.9, which is equal to 1. So the sum to infinity of that particular sequence is, if I added them all up, I would get the value 1. Okay, that's all I wanted to say before I let you do some practice. It's really rinse and repeat in many ways. So the textbook, I haven't gone through the most complex examples here. So the textbook references here. So exercise 5, I'm deliberately starting you from a little bit further on. So questions 4, 5, 6, 7, 8, 9. I'll give you about half an hour to have a go at those ones. Note that I have not gone through all the complex different kinds of examples. Like, for example, you might be given U2 and U5, and you might be given the sum to infinity and you need to work out U1. But a lot of it is just using the same techniques that we've looked at before in other series problems. It's just that we're applying them to a sum to infinity. So I don't want to overtalk it. I just want to give you a chance to have a go at them yourself, and then I can come around and help individuals. And we might do that for about 20 minutes or so and see how people are traveling after that.